Okay, we've been going for a few minutes now, but I just had to get everything set up. So I'm going to try using this whiteboard today. I've been trying to use the math board, and it just seems a little too picky for my taste. This one will let me draw circles without erasing everything. That's a big bonus to me. And I also noticed that it kind of fixes up your writing a little bit, so I can draw a little bit of a sloppy number and I'll try and clear it up as best as possible so it's a little more legible. So I'm all cool with that. So today we're going to look at decimals and percents. So if you saw my last video, I believe we're doing fractions, and I kind of was doing it on my own to turn them into decimals. And that's what we're going to do on this coming up lesson. We're going to turn decimals or fractions into decimals and then back again. We'll perform operations with decimals, rounding off decimals, define what a percent is, convert percents to decimals and back, and convert fractions to percents and back. So we're still in the simple stuff. I mean, if this is new to you, it might not be simple, but if you've done any type of math, then this should be pretty simple, easy stuff. I think even if you don't know it, it turns out to be pretty simple. It's still the basics. So we're gonna kind of show like numbers on a decimal point. So see, old habits. I drew a circle to erase. Anyway, so let's say we have a number 1. So we would say this number 1 is in the ones place. I don't like drawing that there. I'm still kind of figuring this out too. Nice circle it drew. There's got to be a different way to erase too, though. But oh yeah, you do. So let me do this. Try and give you an idea of what we're doing here. So if we have a line. So if we had like 3, 6, 5, we'll put a 4, a 3. So let's say this was our number, 34,563. The 3 here is in the ones place. The 6 here is in the tens place. The 5 is in the hundreds. 4 is in the thousand. And the 3 is in the 10,000s. And you can tell that also by the way we say it. So anything here, 1 through 9, is just 3 in this instance. If it was a 7, it would be 7. Now when you add a number in the tens place, so you're talking 10, 11, 12 up to 99, that's how you say the number, 63. Or if this is a 5, 53. Or if, it could be 47. 47. This is the ones, this is the tens. So this is the ones, this is the tens. The 5 should be here. Let's fix that 5. So this is the hundreds place. This would be the thousand and 10,000s. So listen how we say it when it's in the hundreds. 563. Thousandth place. 4,563. 10,000s. 34,000. So it goes back to how we say it here. If this was a 6 and a 3, it would be 63,563. And then you can keep going. You'd have 100,000s. So you could say 434,000. 400. And then the next one would be the millions. 6,434,563. Now, conversely, if we keep going to, so the number gets smaller as you go from right to left. So 63 is definitely smaller than 6,400,000. But the number can keep going smaller. So you can have numbers here. So just for number's sake, I'm going to get rid of all of this. Oops, I'm still drawing circles. We'll say 63. Let's get rid of this up here too. So this is our decimal point right here. So in a situation like this, 63 point, if we just have the 1, we would say 63.1, and that's the tenths. The next number is the hundredths. So we would say 63 and 1600ths. The 8 is in the thousandth place. So we would say 63 and 168 thousandths. So you can see the number gets rapidly smaller going in this way. So these are fractions of 1, what you're saying. So you're saying you have 63, but you're not making it to 64. You're falling somewhere short. So if this is 63 and this is 64 back on the number line, you know, if you divide this up into 10, 1, 2, 3, 4, 5, 6, 7. So if you had 10 units to get from one number, 0.1, this would be 0.1. Because that's a tenth, 1/10. If this was 0.4, you'd be 1, 2, 3, 4. You would be here, 0.4. And then the next number, this is kind of like how the metric system works. If you divide this up into 10 spaces, from 0.4 to 0.5, that would be what the 6 represents, hundredths. So now you'd be going 600ths in here. Or if this was a 0, you would just be going on the first 600ths, which would be about here. Because it'd be 10 smaller dashes between here and there. You can see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So it just keeps getting smaller and smaller till you get out. Let's see, 6 would be in the hundredths, 8's in the thousandths, 4 is in the tens of thousands, 5's in the hundreds of thousands, and if you had a number out here, that'd be millionths. So if all of these were 0, except for this being a 9, you would say 63 and 9 millionths. So now how are we going to do this in math? Let me see if this is a quick erase here. Boom. Like that erase. Let's go back to here. Okay, so what we want to do now is write this as a mixed number. So we have 32.15. We're gonna write this as a mixed number. So we're gonna rewrite 32.15 as 32 plus 15 over 100. And I'm guessing that the reason why we want to do it over 100 is because 5 is in the hundredths place as far as decimals go. So if we just had 32.1, it'd be 1 over 10 because it's in the tenths. If we had 32.156, then we want this to be in the thousandths because we're doing by thousandths. So 15 over 100 can reduce because we know 5 goes into both of these, so we can reduce that to, let's see, 5 goes in there 3 times, to 3/20ths. Whoa, I can zoom in and out. That's cool. Oh, and I can move it around. Sweet. So now, let's rewrite this so it's easy to understand. Whoops, I'm in a different mode now. How do I go back to drawing? Here we go. So we have 32 plus 3 over 20. Look how nice it made the 0. And now we have our mixed number. There's our answer. I expected a lot more to come out of that. So now let's say we start with the decimal. Oh, we're still... So now we want to do convert a fraction to a decimal. So let's start off with something fairly easy. We have 3/4. I can tell you right now in a decimal, it's going to be 0.75. So let's find out how we get to that answer. So we're going to divide. Remember, when you see a fraction, it can also be written this way. That's just telling you to divide. So back in elementary school, we learned how to do this, division. 4 goes into 3 0 times. It doesn't fit. So let's find out. Oops. That's... So we want to make a 0. Now we know 4 goes into 37 times. That makes 28. Remember, there's a decimal here. So we go 28. 4 goes into 25 times. 0.75. Okay, now we want to do... Now we want to write as a decimal 2 5/6. So let's scroll up here. I wonder if I have an infinite scroll now. That'd be great. Because then I can always scroll back to show what happened earlier. That's been needed a few times. Okay, so what do we need to do here? We got, oops, gotta click the pen. 2 5/6. And we want to write this as decimal form. So remember, first we want to convert that. So we'll use long division. 6 into 5, that doesn't work. So let's draw a decimal, make it 6 into 50. And we know 6 goes into 50 8 times. 48. That makes 20. Drop down another 0. 6 goes into 20 3 times. 18. Makes 20 again. So we found ourselves in a loop here. So we just draw a line over the last 3, and that tells us that the 3's are infinite. You could do this too, but trust me, you just want to draw the line. So now that we did the long division on this part, we can go 2 plus 0.8 3. And the hat tells us that 3 repeats for infinity and beyond. And there's your answer. Now let's do some subtraction. So if we have something like 54, 0.328. If you want to say it the right way, you'd say 54 and 328 thousandths. Or you could just say 54.328 minus 23 and a quarter. 23 and a quarter in decimal form. Boom. So the easiest way to do this is to line up by the decimal points. So your decimal point is here. Decimal point here. What do we have? 25. It's blank here, so there's nothing in the thousandths place. So we got here we have a 10, 100, and a thousandths. It's just 0. You don't have to draw in the 0 though, but just so you know, that just means 0. So going back to a while, when you see 500 or 54 minus 23, and you're gonna rewrite it like this, it's basically an addition problem. You're adding negative 23 to 54. So you're taking away. So you put the subtraction sign here. If you were dealing like with money or something, you would say, okay, we made $54 on this transaction. We lost 23 on this transaction. What is our total? Anyway, so subtraction, we got 8 minus 0 is 8. 2 minus 5, we know how that works. You borrow from here. 12 becomes 7. 2 minus 2 is 0. 4 minus 3 is 1, and 3. So you end up with 31.078. Now when you do multiplying, so subtraction, addition would work the same way. You would still want to line up. If you change this to an addition problem, you still want to line up the decimals. Then you would say 8 plus 0 is 8. 5 plus 2 is 7. 2, or it would be a 3. 3 plus 2 is 5. 4 plus 3 is 7. And 5 plus 2 is 7. So your answer would be 77. So adding or subtracting, make sure the decimals are lined up. Multiplying is a little bit different though. So multiplying, let's say we have 5.36. And we want to multiply that by 7.4. You're not going to line up by decimals here. You're just going to line up by number, because remember in multiplication, first number you multiply across, right? That's the rule. 6 times 4 is 24. You pop the 2 up here. 4 times 3 is 12, plus 2 is 4. Add the 1, you get 2144. Remember, add a 0 when you're moving over. 7 times 6 is 42. Now you're going to put the 4. That makes 25. Remember, always carry the tens place. You only place the ones place. And then 35 plus 2 is 37. You're going to add these together. So you get 4, 6, 6, 9, 3. Now what you got to remember is that you were multiplying with decimals. How many numbers are to the right of the decimal point? That's your key here. So 1, 2, 3. 2 up here, 1 down here. So you want to move 3 over. 1, 2, 3. There's where your decimal point goes. So your answer is 39.664. Okay, now this part always has tripped me up forever. Dividing by decimals. Or dividing with decimals. So let's take 33. Let's make this decimal so it's obvious. 3216. And we want to divide 6.24. So you're going to write 6.24 divide by 33.3216. What you want to do is move the decimal places to the left to make this, the divisor, into a whole number. So 1, 2. Now, since you did it to this side, you have to do it to the dividend. So 1, 2. So it now becomes 600. Let me write this a little lower. It now becomes 624 divided by 3,332 sixteenths. And then you do the problem like you normally would. Guess what? I'm not even going to bother with this one. So 624 goes into 3,332 times. It will go into that, and it's going to be approximately 5. Let's see, 624 times 5 is 0, 2, 12, 1. Yep, 3120. And then you get 212.16. So the point goes up here. And then 6 goes into whatever. Let's see, 624 would go into 21. That'd be about 3 times. And then you just work out the problem. Now, sometimes we just want to round decimals off to a specified number. Then we can approximate decimals with fewer significant digits. I mean, there's going to be situations where, you have, maybe you're measuring something out to 5. It has, some type of job where you have to do this thing, and it's just 5 point. Let's say this is in inches. 5 point, 1, 3, 6, 2, 1. Well, in this situation, excuse me, for what you're doing, it's probably easier just to, this is 10 thousandths of an inch. We don't need to be that accurate. Maybe this is as far as we need to go. And we can just round up to 14. Or maybe we need to at least go to thousandths. So then we would keep it this. Anyway, let's see what the book says. So when we're rounding off, here's the main rules. If this is your decimal, and you have 6, 4, 9, I'm just going to draw a bunch of random numbers, and you want to round to the tenths place. Here's the tenths place. If the number to the left is 4 or lower, then the number stays the same. If it's 5 or higher, then you move the number up. So in this case, the number to the left of the 6 of the tenths place is 4 or less. So you would, if you were just rounding to 10, the answer would be 0.6. Now if you were rounding to the hundredths place, well, the number to the left is 9. That's 5 or greater. So then you would end up with 0.65. Now when you're rounding, you're also going to use a new symbol. So we're rounding this one to the hundredths place. You don't say equals, okay? Because we're rounding. 0.65 does not equal this. So you want to change the equal sign to the wavy equal sign. So it basically means approximately, around. So 0.64937 is approximately 0.65. That's what that's saying. It's saying close enough for government work. So here's an example of when we would want to round things off. Let's say we're dealing with money, and we want to find out what 1/3 of $10.25 is. So since we have the 1/3 of, we want to multiply. So we get 1/3. Now there's a couple ways you could write this, with the dot here and then 1025. Or you could put 1025 in parentheses. I believe you can also just do this. It's just given that you're going to multiply. Not sure on that, leaving a blank. So this can be rewritten as over 3. 1 times 1025 is 1025. Well, sorry, not over 3. That would be over 1. 3 times 1 is 3. Now you have a long division problem. So you end up doing the long division of 3, 10.25. You get 3 goes into 10 3 times at 9. Here's a decimal, so remember to put the decimal. You get 12. 3 goes into 12 4 times. So that's a 0. 5. 3 goes into 5 1 time. 3 times 1 is 3. So now you get 2. Bring down the 0. You get 20. 3 goes into 26 times. 18. 2. Now we're going to be stuck in a loop because that's going to be 20. Now remember though, we were dealing with money here. We wanted to know what 1/3 of 1025 was. So we come out with an answer of, this literally equals $3.3. Oops. Let's get rid of this little hat. So $3.41. Well, what is this? We can't have thousandths of a penny or thousandth of a dollar. So we need to round. This hat tells us the number to the left is also a 6. That's 5 or higher, so we would round up. Well, actually, we want to round the 41. My mistake. We don't even care about that because we only want to round to the 100th. So the number to the left is 5 or higher, so we're going to end up with 3 point. So $3.42. Whenever you have labels too, you want to write your answer with the labels given. Okay, let's do one more. Let's say we want to know what a 1/4 of 1025 is. So we have a multiplication problem. Now remember, you don't have to put the 1 there. It's a given, but if it helps you remember what you're doing, totally fine. 1 times 1025 over 4. Now, as you become more familiar, this is something that you can, a step you can skip. You can just go from here to there because you would automatically see, okay, boom, just combine it. And you could even just skip this step and just go straight to this step. Now in school they might want to see one of these 2 previous steps, but the reality is if you see something like this, oh, I need to find what 25% of 1025 is, or 1/4 of 1025. Well, I recognize that it's 1/4, so you recognize that it's going to be this, and you can pretty much do in your head, I need to do this. So now we have 4 goes into 10. What, twice? For 8. 22. Don't forget the decimal. Four goes into 22 5 times. 20. And we get 25. 4 goes into 25 6 times. We get 24. Now we have 10. 4 goes in there twice. Now we could keep going, but this is where we're going to stop. Because remember, we're dealing with money here. And it doesn't really matter what's here. If we kept on going, then we'd have 10. 4 goes to 2. We got 8. 20 left over. It only goes one more step anyway. So this is the answer, equals, but we want to round because we're dealing with money. And we only need to go to the hundredths. The number to the left of the hundredths and the thousandths spot is 4 or lower, so that stays the same. So our answer is $2.56, approximately. Oops, don't forget to do that. Okay, now we get to do some percents. Percents are pretty simple too. So a percent is just a representation of a number as part of 100. The word percent can be also written as 2 words. Well, big deal. So it means per 100, because like 100 cents makes $1. This is our symbol for percentage. So the formula for percentage is n%, n being any number, is equal to n over 100. So 5% is equal to 5 over 100, which equals 0.05. Now remember, I think looking at this, thinking of money helps when it's in decimal form. So $1 is 100 pennies. A nickel is 5 cents. 5/100ths of a dollar. So 1 penny is 0.1. 10 cents is 1 0. That's a dime. A quarter is 0.25. And why I think it helps is because think of a quarter. How many quarters make a dollar? 4. It's 1/4 of a dollar. How many dimes? 10 cents go into a dollar. We all know that's 10, so it's 1/10 of a dollar. If we had 10 dimes, we equals $1. So what happens if we multiply 10 to this? We end up with 10 over 10. That doesn't look like a 10. That, and 10 over 10 is equal to 1. So if you think about the decimals and change towards a dollar, I think it really helps make the rest of it a little bit easier or make a little more sense. And anyway, that's what's always worked for me. So if you have like 72%, that's equal to 72 over 100. Which is equal to 0.72. So 72 cents. Now what about 100%? That's equal to 100 over 100 equals 1. Kind of like what I was just saying. Now, what if you had greater than 100%? What if you had 135%? Well, remember, it's out of 100. So you have 135. You're going to end up with 1.35. I think I'm liking this whiteboard better than the math board that I was using. So common ways of expressing percents you would see is like in a pie chart, where let's say, they ranked how many people liked pepperoni pizza, or what their favorite pizzas were. So pepperoni, they did all the kids. Pepperoni got 3/4, so that'd be 75%. Sausage got, or cheese got 20%. And sausage was 5%. And then over here, these might be colored in different colors. So like this might be all colored in red. This might be colored in purple. And then over here it would have a key, and it would be like, okay, purple equals sausage. And then, whatever color this was equals cheese. Red equals pep. So if we have 152% and we just want to convert it to a decimal, the easiest way to do it is just to move the decimal over 2 places. 1, 2. And you have 1.52. So that's converting to a decimal. If we have 2 3/4 and we want to convert that to a decimal, the answer is 2.75. And then we move the decimal over 2 places. And you might be asking, well, wait, why does 2 3/4 equal 2.75? Remember, you're going to take the fraction and do the long division. So 4 goes into 3, 0 times. Now you're going to place a decimal. 4 goes into 37 times. 28 is 225. So there you go. You can finish the rest of that if you want yourself. So we have 2.75 Now remember, we want to convert this to a decimal. So we're going to move the decimal over to the right 2 places. 1, 2. So we're going to put a 0 here. Remember, we moved the decimal here. So now our answer is now sometimes people want you to put the 0 here before the decimal. Maybe I was just being a little bit contrarian here, but I hated writing that 0. I never would do it. So now let's take 215% and write that in decimal form. So all we're doing is dropping the percent sign. Now we got 215. The decimal would be there. Move it over to the right 2 places. 2.15. Now, decimals and fractions to percents. So if we want to convert 0.23 to a percentage, first we're going to convert it to a fraction and then apply the definitions that we learned. So we just turn it into 23 over 100. 23 over 100 equals 23%. The easiest way to do this, move it to the left 2 spaces. So now you have 23. Add the percent sign. Okay, let's take 5 1/5. Remember, do the long division first to convert it to a decimal. So we'll have 5.2. Now we want to make this a percent. So which way do we go? This way. 1, 2. So the answer is 520%. Okay, now let's try converting 13 over 25 to a percent. So the easiest way to do this is, remember, we wanted over 100. So we could do this and then do all the hoopla that goes with that. Or we can just say, to get to 100, we need to multiply by 4. Thirteen times 4 is 52. 25 times 4 is over 100. See, now we're over 100. And that equals 52%. So what happens when we don't have a multiple of 100, so let's say we have 1/3. So we're going to end up going 1/3 times 100%. Well, that comes out to 100 over 3. We still have the percent on there. 3 goes into 100 33 1/3 times. So 1/3 is equal to 33 1/3%. Now let's say we have 2/3 and we want to convert that to a percent. Same thing we did back here. Now we have 2 over 3 times 100 over 1. That's going to give us 200 over 3. Remember, this is still percent too. This is percent. Now 3 goes into 200. You can do the long division if you want. I'm not going to. 66. Let's do the long division on this after all, because I don't think the answer in the book is right. Yep. So that's right. I think there's a mistake in the book here. You would end up with. Actually, you do that. And then you could just round up. Okay, now let's convert into a fraction. So you have, let's say we have 28%. Well, we're going to go 28 over 100. But we can reduce that. So what's the number that goes into both of these? 4. So if we divide by 4, we're going to end up to divide both sides by 4, we're going to get 7 over 25. That can't be reduced anymore. Now let's convert this to a fraction. 66 and 2/3%. So remember, we want to multiply by 100. So we're going to end up with 200 over 3. Oh, you want to make sure you label things. Okay, now we want to divide by 100, which puts us right back to where we started from, doesn't it? So now we divide by 100. Now remember, when we're working with division, we want to do a reciprocal to make it a multiplication problem. So now we're going to go 200 over 3 times 1 over 100. Cross cancel, 100 goes in 1, 2, so we end up with 2/3. I'm going to write this as a percent. My only complaint is they wrote the problem out as 66 and 2/3. They should be writing it out as 66.67%. And then we're converting it to a fraction. Anyway, I think we're going to wrap it up for today. Just remember when you are convert a decimal to a mixed number to add the appropriate fractional parts indicated by the digits to the right of the decimal point to the whole part indicated by the digits to the left of the decimal point, and then reduce if necessary. To add or subtract decimals, remember, so if you have 4.65 and you want to add or subtract that to, 7.14, you need to make sure everything's aligned up. If you write it all sloppy, 5, 1, you're going to get all confused. So just line up the decimal points. The answer will also, this can be plus or minus. So just make sure the decimals are lined up. Remember, doing multiplication, if you have 4.76, you're multiplying it by 3.2, you don't line it up. You want to do it like this. So you want to just basically have a wall here and then line everything up going this way. Do the multiplication problem as you would. And then when you get the answer, so whatever the answer is, count how many decimals or how many numbers are to the left of or to the right of the decimal. In this case, we have 3. 1, 2, 3. That's where you place your decimal point. When you're rounding, let's say we want to round 4.76 to the nearest tenths. We're going to take a look at the number to the right. If it's 4 or less, this number stays the same. If it's 5 or higher, so in this case, if we were rounding to the nearest tenth, it would be 4.8. If, let's say we were doing that to 3.231, we wanted to round to the nearest tenth. Well, the number in the hundredth spot is 4 or less, so we'd keep it the same, 3.2. Remember, a percentage represents the number as part of 100. That was n% equals n over 100. And that's about it for today. This one can be a little tricky. Even what I showed, it's probably still not clear for a lot of people. I get it. Um, it's clear enough to me to want to move on, though. This is a section, though. If you're learning these and you're not clear, I think just finding problems until it clicks is the best thing you can do with this. Even if you don't get it, I don't think it's enough to keep you from moving forward. If you're in a math class or something like that, just go back to it and revisit. Put a check mark in this or bookmark in this part of your book or whatever you're learning from, some way so you can reference this material. It does get a little bit tricky. It always gets tricky for me, but it's easy enough that if you go back and review it, then you're good to go. Anyway, that's it for today.